Picture this. It is early 2025, and beneath the impossibly blue waters of the Aegean Sea, something is stirring. Over just a few months, nearly 30,000 earthquakes ripple through the sea floor between two of Greece's most iconic volcanic systems. Tourists are still snapping photos of Santorini's whitewashed clifftop villages, but deep below, roughly 2 to 4 kilometers beneath the waves, magma is on the move. What scientists discovered during this crisis has fundamentally changed how we understand volcanic hazards in the Mediterranean. Here is where we stand. A landmark study published in Nature in late 2025 confirmed that the Santorini Caldera, the one famous for that catastrophic Bronze Age eruption, and the nearby submarine Kolumbo volcano share the same deep magma source. During the 2025 seismic crisis, instruments recorded approximately 30,000 earthquakes, surface inflation at Santorini, and simultaneous subsidence at Kolumbo. Satellite radar and ground-based GPS stations captured a roughly 13-kilometer-long magma-filled dyke, a blade of molten rock propagating laterally between the two volcanic centers. Greek authorities declared a state of emergency during the peak activity, and officials clarified that a dramatic eruption was not immediately imminent. The magma moved, the crust flexed, and scientists got the clearest view yet of how these volcanoes are plumbed together. So what does it actually mean for two volcanoes to share a magma system? Let me explain. Think of the crust beneath the Aegean Sea like a layer cake with a very active filling. At depth, there is a large reservoir of partially molten rock, magma, sitting in what we call a mid-crustal storage zone. This is not a cartoon lava lake. It is more like a sponge saturated with honey, where pockets of melt are distributed through hot, semi-solid rock. Both Santorini and Kolumbo tap into this shared reservoir, like two straws drawing from the same thick milkshake. During the 2025 crisis, pressure changes in that deep reservoir forced magma upward and outward. Instead of feeding just one volcano, the magma migrated laterally through the crust, intruding into a dyke, a vertical sheet of molten rock that sliced through existing fractures. That dyke extended roughly 13 kilometers, or about 8 miles, connecting the plumbing beneath both volcanic centers. As magma moved towards Santorini, the ground there inflated slightly, and as it drained from beneath Kolumbo, the sea floor above that vent subsided. It is a bit like squeezing one end of a water balloon and watching the other end bulge. This kind of coupled behavior had been theorized before, but the 2025 earthquake swarm gave scientists a natural experiment. Tens of thousands of tiny seismic signals acting like ultrasound-like pulses, illuminating the hidden architecture of the magma system in real time. Let's get into the numbers, because they are remarkable. The Nature study, published September 24, 2025, integrates data from GNSS ground stations, InSAR satellite radar imagery, and dense seismic arrays deployed around the Cyclades. Together, these instruments captured roughly 30,000 earthquakes over the early months of 2025. Most were small, magnitude 2 or below, but their sheer volume and spatial distribution allowed researchers to map the geometry of magma pathways with unprecedented detail. The magma-filled dyke itself measured approximately 13 kilometers long, or about 8 miles, and propagated through crustal rock at depths between 2 and 4 kilometers below the seafloor, roughly 6,500 to 13,000 feet. For context, that is deeper than the Grand Canyon is tall, but shallow enough that surface deformation was measurable from space. How does this compare historically? Santorini's last significant eruption occurred in 1950, a modest event by its standards. The catastrophic Minoan eruption around 1600 BCE, the one that may have inspired the Atlantis legend, ejected an estimated 60 cubic kilometers of material, or about 14 cubic miles. No one is suggesting that the 2025 activity signals anything close to that scale, but understanding how magma moves between reservoirs, is exactly the kind of insight that helps volcanologists distinguish routine unrest from genuine precursors to eruption. Kolumbo itself last erupted in 1650 CE, killing dozens of people on Santorini from toxic gases. It remains one of the most hazardous submarine volcanoes in Europe precisely because it is so close to inhabited islands. During the peak of the 2025 seismic crisis, Greek authorities issued a state of emergency for parts of the affected region. Residents and visitors on Santorini felt sustained tremors, and some buildings showed minor cracks. Ferry schedules were briefly disrupted, and local civil protection agencies coordinated public information campaigns to reassure communities that the seismicity, while unsettling, did not indicate an imminent eruption. Scientists from Greek universities, the Hellenic Center for Marine Research and international collaborators worked around the clock to process incoming data. The crisis became, in effect, a massive natural laboratory, one that yielded the Nature paper and will inform volcanic hazard assessments for years to come. No fatalities or serious injuries were reported. But the psychological toll of thousands of earthquakes over weeks should not be underestimated. Living through sustained seismic unrest is exhausting, even when the ultimate outcome is calm. So what would it take for this system to actually erupt? Let's be direct. The 2025 activity involved magma movement, but not magma reaching the surface. The dyke intrusion stalled at depth. For an eruption to occur, you would typically need sustained, escalating seismicity. Think thousands of earthquakes per day, trending upward rather than stabilizing. You would also need rapid surface inflation, increased volcanic gas emissions, with sulfur dioxide as a key tracer, and possibly harmonic tremor, a continuous seismic signal that indicates fluid flow through open conduits. None of those late-stage indicators reached critical thresholds in 2025. The system pressurized, adjusted, and then quieted. That is actually the most common outcome for volcanic unrest episodes worldwide. Magma intrudes, the crust accommodates the stress, and equilibrium returns without eruption. However, and this is important, the discovery that Santorini and Kolumbo are coupled changes risk calculations. An eruption at Kolumbo, a submarine vent, could generate tsunamis affecting nearby islands. An eruption at Santorini could impact the 30,000 or so residents and the roughly 2 million tourists who visit annually. Knowing that stress changes at one volcano can influence the other means monitoring must account for both systems simultaneously. Greek and European monitoring agencies continue to track seismicity, ground deformation, and gas emissions across the Santorini-Kolumbo complex. Expect updated assessments every few weeks during quiet periods, and more frequent bulletins if activity resumes. Researchers are also planning seafloor surveys near Kolumbo to install additional sensors directly above the submarine vent, getting closer to the action, so to speak, for earlier detection of changes. The Nature paper is already being integrated into regional hazard models. This is science working exactly as it should. A natural crisis reveals new data, that data refines our understanding, and better understanding improves preparedness. If you live in or are visiting the Cyclades, stay informed through official Greek civil protection channels. Know your nearest evacuation routes and high ground. And remember, the presence of monitoring equipment is a sign of safety, not danger. Scientists watch these volcanoes precisely so. Communities have time to respond. Here is the bottom line. The 2025 Santorini and Kolumbo crisis did not produce an eruption, but it produced something almost as valuable, a detailed map of how magma moves beneath one of Europe's most closely watched volcanic regions. That knowledge protects lives. If you found this breakdown helpful, subscribe to stay informed on geoscience developments worldwide, and share this with someone who deserves calm, evidence-based explanations instead of hype. We will keep watching the data so you do not have to guess.